Welcome back for one more. So here's our last equation to solve. A equals the sum of x, y, and z over 3. We got to get that thing knocked down to solve for x. So once again, we're gonna refer back to our list. We have to get from x to that expression in the correct numerical order. Now, one way that's helpful to think about what has to happen first is to fall back on your order of operations. But a lot of times when I say that, students might think of different things. Like, what do you mean order of operations? So here's another way of thinking about it. If you actually had numerical values for all of these things, what would you do in what order to evaluate them? So in class today, I told a couple students, what if x were 1, and y were 2, and z were 3? What would that right-hand side be equal to? And all the students I asked said the same thing. Well, they said, well, 1 plus 2 plus 3 is 6, and then 6 divided by 3 is 2, so it would be equal to 2. I said, heck yeah, that's exactly right. So what did you do first? And they said, well, we added up the x and the y and the z. And I asked, well, why would you do that? And then the answer is order of operations. So, even if you don't have values, you know in the back of your mind that order of operations say those things have to be added first. So the first thing that has to be done is you have to add y plus z to x to make x plus y plus z. And then you divide both sides, you divide it by 3 to get to that expression. So you know the order of operations. What a lot of students forget, I think, is that there are parentheses around that, that numerator of that fraction. I used to teach 95 a lot, and I used to harp on, please excuse my dear Aunt Sally. I think it's a piece of crap, because it leaves out important things like fraction bars. Fraction bars are in the same place as parentheses on the order of operations line, but there's no FB in that acronym anywhere. Make up a fun one for yourself, though. All right. So anyway, we can now, if we know the steps, we can undo. We know that to get from here to here, we added y and z, and to get from here to here, we divided by 3. Well, now we can undo all that, can't we? We can undo division by 3 by multiplying both sides by 3. So if you multiply this side by 3 and this side by 3, you get 3a over here. This part, I saw some students getting some confusion. The whole point of identifying this Lego chain of events here is the fact that if you can identify what to undo, you get back to this. Which means this is going to undo this and leave you with x plus y plus z. It's going to get you right back to that step, which is fantastic. And then the last step, we had to add y and z to get from here to here. So we're going to subtract y and subtract z to get 3a minus x, minus y minus z equals x. So that's as far as you can go. You can't give me a single numerical value for that. There's no single numerical value to be had. This is an equation that's based on 3 other variables, a, y, and z. So this is what's called a literal equation or a formula. I have a whole project for you guys for week 3 based around this idea and this Lego idea, which is also included in that project. I think it's that important. Even if we're not in an strictly algebra-based class, I still think it's important enough to have a good set of algebra skills to attack these problems. So anyway, the reason I like this formula, I don't like just making up formulas either. This formula, you've used it before in your life. It's your average of 3 scores. And I bet you a bunch of you have done this too. Figure out what score you have to get on, say, exam 3, given your 2 exam grades 1 and 2, and an average that you might want. So you might want an average of 90 or better, and you know you got an 85 and an 87. What would you have to get on exam 3 minimally to get an average of 90? Well, you can figure that out. 3 times 90 is 270, and take off the 2 grades, which I've now forgotten what I said. And that will tell you what you have to get on average on the last one to get your desired grade. So it's a useful formula, as they all are. At least they should be. So I hope the video has helped you get through some solutions. We'll see you in class.